Yeah. Uh, Good morning, people. So I'm Arun Magesh. So I work at Paya2. So I primarily work on hardware and also SDR pen testing. Yeah. So this is my first talk in the software SDR redefined workshop series. So since previously we have seen the previous talks were mostly into hardware hacking and a little bit on DSP on how it really performs. So the whole point of those two workshops is basically to give you a understanding why you need to learn SDR and how is it really connected to IoT pen testing or hacking into IoT devices. Yeah. So in this talk, I'm going to talk a bit on SDR toolchain as in the type of hardware you have to use and the type of softwares you have to use, and then I will give you a little introduction on how you can really use those tools, what are the options, how you can get maximum out of these tools. Yeah. So today's agenda, I will talk a little bit on RTL SDR, so that most people might have heard about it. So that is like the cheapest SDR you can get it in the market. So you can get it from what $15 to even $50, which is a good quality variety of your RTL SDR. And then GQRX is a Linux-based SDR receiver. So where there are a lot of operations you can perform, like saving it or watching the waveform plot or performing a bit of FFT and stuff. And SDR Sharp is also similar to GQRX, but it's primarily for Windows. Yeah, I mean GQRX has more features considered SDR Sharp, but it's always a trade between a Windows or Linux machine. Yeah. So RTL SDR, as I told you, it's like super cheap. So you can get it as low as like $10 in China. So let's say in AliExpress, you can get these dongles for less than $10 or $15 or $20. Yeah. So basically, how SDR really started is, so before even the SDR came into picture, so previously this is basically a TV transceiver. So what happens is, like, there are companies which are selling proprietary TV receiver. So a researcher in 2010 reverse engineered the communication, and then he figured out that the device can also be used as SDR, and then people started developing it, backing him, and then people started creating RTL SDR, and then now RTL SDR has boomed in a complete different horizon. Yeah. So as I told you, it's also a TV tuner. So you can also use this to watch your free Spectrum TV, but you need a powerful antenna. Yeah, that's still possible. There are softwares like SDR TV or SDR Watch, so where you can really connect it and then you can watch TV if you have a proper antenna and all those stuff. Yes, and the frequency here, the SDR works is from 24 megahertz to 1.766 gigahertz. So that basically covers your basic RF, your FM and AM transmission, so your ADSB and multiple low frequency or sub gigahertz based frequency. And if you look at Wi-Fi is 2.45 or 2.5, so you can't really sniff anything with respect to Wi-Fi or ZigBee, which uses the 2.5 gigahertz using this transceiver. There are other tools like HackRF, PlaneRF, which supports still 5 megahertz. So that's a little expensive, consider this $15 to $20 device. Yeah, and it won't only receive a signal, you can't really transmit it back. So this is only a receiver. But there are few hacks available where there are some internal rewiring the PCB, not like rewiring, it's like connecting different output. So you can convert RTL SDR also into a transmitter, but with the cost of tampering with the circuit board, removing few inductors, and then channeling it a different pin to the antenna, and then you can also transmit it. And since it's a super cheap device, the market has been like super wide. So there are a lot of supports for Windows and Linux system, even Mac OS. So even then, there is something called as GNU radio. So right now, this is going to give you a raw input. Let's say you are going to let's tune into a frequency where, let's say, it's a pager frequency, let's say around like 725 or 730, then that is where your pager communicates or your ham radio communicates. So this gives you the raw data. You can't really do much about it because they use multiple types of modulations. There are a lot of modulations like FM, AM, QPSK, OOK modulation. So they use these modulations to transmit data over the air. This can only receive those modulated waveform to get your real wave. So there are a lot of digital signal processing which you need to perform. So that there's a tool called this GNU radio. So it is more like a block-based DSP processor. So where there are a lot of processor, let's say you can create a source, you can add filters, you can perform FFT, FIR filtering, and then using these basic techniques, you can really retrieve the original signal. So the whole point here is, whole point of having a GNU radio is like, let's say for example, you have a smart security system, and then if you really want to pen test it, so what you can do is you can tune into the frequency of which the device really operates, and then you can understand the kind of modulation which they use. In most cases, they will use OOK modulation, that is on-off keying. Yeah, so using GNU radio, you can really decode it and then see how the data has been transmitted. So that is one way of performing your sort of like reverse engineering your wireless communication. So everything can be done using this $10 to $20 devices. Yeah, so we know we just gave you a small introduction, not like introduction, a bit of gist on what you can really use an SDR for, and then how you can really use it. We thought they're a normal example of a normal security system. Now let's go a bit of deep on what exactly the device has, how exactly the device can process everything. So even if you look at this image, so it has like two main components. So the first component is basically your RTL2832U, so which is your USB to ADC. So what it exactly does is, so whatever ADC is basically your analog to digital converter. So if you look at any waveform, so they are going to be basically analog waves, because they are not digital, because they are converted digital to analog and they are transmitting over the air. So ADC is where analog is being again converted back to a digital form in terms of 0 and 1s, or in terms of digital levels, and then it's been transmitted to USB. And then the second one is your tuner. So tuner, the thing is, if you take a traditional old radios where you need to manually tune the frequency, there's a small knob you turn, you switch to a different frequency, and then you hear FM radio. So here in this case, there is a specific IC, so that is R8820T, and that is going to perform the operation in a digital manner, where you don't really need to use a manual knob to control the frequency. So in this case, everything is being controlled in a USB. So your end software tool can also read the data, and also can control the frequency in which we are getting the data. So TV tuner is basically converts your RF data and then sends it to analog data, and then pipes it into the ADC to USB converter, and then you get the data. And other than that, there is a, if you look at here, this is your antenna, your normal antenna where you can plug it in. Also there is a TSOC, your IR receiver. So that is mostly for the, since this device is designed for TV users, like you're receiving TV signals, so still they are using the IR. You can still use it, but since we are using it for SDR application, you don't have to worry about that. Yeah. So now we know that RTL SDR is cheap, but it can only, the frequency range is limited from 20 MHz to 1.7 GHz, and also it can only receive, you can't really transmit it without doing any hack. Yeah, so there are other similar devices which you can get it. So the first one is the most popular HackRF. So the good thing about HackRF is like the frequency range is like really vast. So it's the frequency you can capture from around 1 MHz to around like 6 GHz. Imagine it includes both of your Wi-Fi, both of your Wi-Fi channels, your 2.4 GHz Wi-Fi and also your 5 GHz Wi-Fi. And also it can also transmit. So a typical hack, what you could suggest is, so your car key fob transmitters at a frequency of, let's say, 433 or 314 MHz. So what you can do is you can use GNU radio to dump whatever the frequency, and then capture the packets, and then you can just do a replay attack, and then you gain access to the car, unless the car has a ruling code or any other keying kind of encryption stuff. And also USRP is also similar to HackRF. It's a little expensive, it's more rugged, so the stack is so properly developed, so you can build multiple stuff. There are people who have created their own GSM station by using the USRP. Since this is a software defined radio, you can also transmit and receive, so you can literally create your own wireless protocol. So using GNE radio, so you can modulate a signal, you can get a signal source, a data source, you can modulate, perform multiple modulations, and then you can transmit it. Same goes to Lime SDR and Blade RF. They're also similar, but I mean, it depends upon, because it's a different vendor, different SOCs, so different specifications. Lime SDR supports a lot of stack. The documentation is super documented, that you can build your ZigBee, GSM, Bluetooth, everything you can build it from scratch. Imagine you build an entire protocol, Bluetooth protocol from stack, from your physical layer on how a wireless, really from your basic RF till your main data. Yeah. So now let's start with GQRX. So GQRX is like a best SDR receiver I would always suggest, but it's only for Linux. But if you're still a Linux, Windows or a macOS user, make sure you use a VM and then you install GQRX there and then you run it, because it's like super flexible and then it's more user friendly if you ask me. Yeah. So it's also open source, so it has a lot of tools internally. You can perform multiple operations inside it, and it's written for Linux. It supports a lot of devices. It supports almost all the SDRs you can find. And the base is also here is GNE radio, and they're using Qt. So it supports, so once you know Qt, you can also build your own custom script around it, so you can automate these processes and then build your own applications or build your own framework around this stuff. Yeah, the features is obviously it can detect the SDR that's been connected, and also it can detect the whatever the data amplitude, and the I and Q is basically the amplitude and your frequency data, and you can change the frequency to correction, you can increase the gain, reduce it, and also it has simple demodulators. So let's say someone is transmitting a FM is basically a frequency modulation, so in order to get a real value you need to demodulate it. So the GQRX supports multiple demodulators, let's say AM, FM, wideband, narrowband, your SSP, and lot more. And also it has a AGC, that is basically your automatic gain control. So based upon your signal strength, so your gain will increase and reduce. This is a good feature to have if you are like in a place where you get a good signal. Yeah. And then your FFT plot and waterfall, that is more for visualizing of see like what are the noise levels, what are the frequencies there, what exactly the frequency the main signal is carrying. And obviously you can record and play back the audio, and also the same FFT spectrum analyzer. And then the thing is, like, you can also pipe the same data that is getting from USB, you can also send it to a different location, let's say using TCP or UDP, and then you can perform multiple operations. So you can imagine like you can keep like one single server that has like multiple RTL SDR, and then you can transmit data to a different location, and then you can monitor it. Or else you can create a small connected to a Raspberry Pi, keep it somewhere in the somewhere in a different location, and then you can use TCP to access the RF data from anywhere in the world. Yeah. Now let's start with trying the application. Sudo GQRX, just run it. Yeah, so this is the window you will get. So if you look at here, there are like 4 parts you will find it here. So the top left is going to be your FFT or your analyzer part, and then your right side is basically your control operations, whether what receiver operation, input control, or what kind of FFT operations you want to perform on this analyzer. And then here is where you will get your waterfall plot. Waterfall is also like a way of representing your waveforms. Then here you will get basic information like your audio, whatever you have selected. You can also send it in UDP, or there's a RDS you can enable. If this channel is sending an RDS, you can see all the data from the RDS. Yeah. So now let's select. So in this case, you have to select what device it's connected to. So you can see the list. There you can see multiple devices. But if you are connected RTL SDR, you will get something like Realtek RTL28385 with a serial number. So select it, you just leave everything just like that. So if you want to change any sampling rate or input rate, you can just modify it, but I would suggest you not change anything. Yeah, so now press this play button. Yeah, yeah. So you can look at it. This is basically a frequency. This is where you can change. So what you can change is you can just maybe you can type it directly 098. So 98 point some dot 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 is basically your FM frequency range. So you can just go to individually go and check. So yeah, this is your basically I would suggest always don't try to change this part. So make sure you keep this in the middle of your waveflow, so that it becomes easier. So if you look at this is basically a deviation. So the center frequency is basically 98 megahertz. Yeah, now it becomes 0. So always make sure you keep this 0, so that if you want to change something, change here. You can just use mouse to slowly fix it there. Yeah, and this is your waterfall plot. So this is also similar to this, but here instead of making it in a x-axis, they are changing the color, and then they are using the y-axis as your time. So if you look at it based upon the height, the color intensity changes. So here the range is here, so it's in yellow color. So in this case it's too high, so it has increased to orange. So the whole point is to identify signal in a much better way. What happens is, like, if you get a small spike here, you can't really monitor it, but where if you see it here, you can see a small patch of something there, and then you can identify, okay, when there is something happening in this frequency, and then you can identify, okay, some activity is there, so let's monitor the frequency that's connected, just put it there, and then you can monitor the frequency, record it, or else connect to GNU radio, and then you can perform operations. Yeah, so the first thing is, let's stick with receiver option. Yeah, so first thing I will start with mode itself. So mode, you can see raw is basically just a raw. You will just get what is there, just the noise which you get it anywhere. So best way I can show you is, I can just zoom. Yeah, so raw wave just will give me the raw format of whatever that's there. Now second modulation is similar for AM. Since this doesn't really transmit, it is not really a AM transmission, because it is FM frequency range. So doing a AM modulation in FM is not going to work, because they're completely different. So if something is transmitting AM frequency range, then you can use AM modulation to modulate and get the original audio form or whatever that's being transmitted. Yeah, and next is your FM. So narrowband FM is where so if you look at a normal one second, I'll just zoom it out. Yeah, if you take a normal FM radio, it's not just this point. So narrow FM is basically only if it's like a small pike or if it's too small. In this case, they are using at least 10, I think around like 20.20 megahertz, so 200 kilohertz. So I guess you need a wider band. So right now we are using wideband FM. So in that case, you just have to select wideband FM, and then that will select the entire thing, and then you get the audio in a proper manner. Yeah. So and then there are other modulations. So there is something called as LSB and LSB. So again, I can show you by zooming it. So these are not. So right now I'm giving a context with respect to AM, because you can get AM anytime, because there are AM FM radios available everywhere, and then you can get it. So what exactly LSB and USB is? So these are your sidebands. So this is your lower sideband, this is your upper sideband. So what exactly are sidebands? It's like, let's say you're transmitting something in the center frequency, so you can always get let's keep that as an interference. So you will always get some sort of a same data from mirror in your right and also like your left. So whatever there in your right is called as your upper sideband, whatever is there in your left is your left sideband, and then these are for Morse code. So these are like if you're sending so previously like 20 years back people send data in Morse code like 1000. So where if you modulate it you can get the talk whatever the sound, and then you can remodulate it. So right now let's just stick to wideband FM, and let's just reduce it, and then we are just back to where we are. Yeah, so second one, AGC. So AGC, as I told you, is like automatic gain control. So right now it's in medium, so I can just turn it off, and then you can see the little change in the frequency, because if you change your location of your antenna, so based upon the antenna propagation or whatever the signals are going to come into your antenna, so that is going to get changed. So based on that you can just increase it, then you can reduce it. So screech is something like reducing. It will also modify the gain in such a way that you get only this is mostly for your ham radios. So let's say when someone is talking, so it'll go blank when someone is not talking. So it's more not in the context right now, because you don't really use it if you are more into pen testing a normal wireless communication or something data. Yeah, so your filter band is basically this width, so how much you want to filter it at, the exact frequency. Yeah, filter shape is all like soft, and it's all like same how you want to decode it as. I will just right now put it as wide FM, and then you get the entire the FM radio or whatever the frequency that is in. Yeah. So the second option is input control. So your RTL SDR has an automatic gain control. It has an inbuilt automatic gain control. You can also enable it. You can see a variation. So you can see a bit of spike because your AGC got enabled. So based upon the signal strength, the hardware itself will increase the gain. So here if I disable it, you have to manually set your gain. So you can see, so once I reduce the gain, there's no signal. Once I increase the gain, I'm getting the real signal. And then if I say I am just putting it down and then entering it, now I'm getting it full. And then your DC remove, that just removes the DC components. That is also not much of the context, because you hardly use that option. And also for swap IO, so if you see, it just swaps the two axes. Yeah. So the frequency correction, what happens is, so 98.29 is going to be one single FM station, or it's going to be that, but the waveform is little drifted. So you can use this to correct those drift. So if you watch slowly, you can see that moving, or I'll just put it 0, and then I'll just zoom it to show you how that works. Yeah. Yeah. So ppm, if you see, so you can literally move the waves. Where do I show? Yeah, I will take this. So you can see one single line, right? So now if I modify this, you can see that it's being moved a bit. So you can see this is my center point, and there has been small deviation there. So basically what happens is like there's an internal clock in your RTL SDR. So there are times the clock might not really work based upon the different condition. So you can use this to correct your the frequency based upon what you have it there. And then RX, you can't do much because the antenna only supports RX. Yeah, now let's go back and keep it in the middle. Yeah. So now let's talk about FFT. So FFT is basically it's called as fast Fourier transform. So in simple words, so what happens is, so you usually a normal so right now what happens is, so this is your amplitude and this is your frequency, right? So in this situation what we will do is we'll just invert it. So it will show something like this. This is your FFT. So here the main frequency we will set it. So main figure is 98.3. So this is your 98.3 will be in the 0. So this is your primary FM. I can just, yeah. So you see now this is my primary. Yeah. So this is my primary. So I get a huge spike only in there because the majority of the frequencies amplitude is somewhere there. But if I expand it, so you will find a lot of similar frequencies, because so see here, if I increase, this also increases. So based upon the frequency ranges that is there, so here also the data changes. Here also you can increase the gain, reduce it. You can record the entire conversation, or you can record if it's from radio, or if it's a digital data, you can just record it, and then you can open it in a GNU radio, and then you can modify it. And this is your frame rate. That is obvious. So it increases the frame rate. 15 is going to be slow, 30 is going to be fast, and then time span is also like how fast you want to perform the DSP operation with whatever data. It's more like sampling, and pan adapter is basically your UI stuff. And also this is also to change the width or the color. It's more like keeping a threshold. Let's assume you don't like the blue color, you can just change it to something else, and then you can just look at it in a different way. Yeah. Now you can see there have been change. So background is red, and then it's going to be white. So this is more on the UI part, how the representative is. And then you can zoom into it if you want to go into specific frequency. So you can literally see the samples. If you monitor, this is basically like one low. It's not like an analog. So basically these are your digital data that has been represented as analog. And then from a long distance, it looks like it's an analog data. And that's how your ADC works. I can just reset it. Yeah, and then 50 input control receiver is there. Okay. So also there's something called peak. You can select where exactly is the peak in this. Then you can hold it. That's like pretty much everything you get it there. Yeah. So I think this is pretty much it for the GQRX. Yeah. So now let's go to SDR Sharp. SDR Sharp, I am running it in my VM. There are some issues because you are piping the entire data inside the VM, and then there are a little bit of lag or a little bit of unwanted stuff that's there. Yeah, so this is my Windows. I have already it's there. So it also SDR Sharp. You can just download it in their SDR Sharp website, and then you can just run it. Yeah. Since it's a VM, I need to pipe it. So I will get it as RTL 2838. I just select it. The driver is already installed, so it's connected. So I have to just select it, RTL SDR, and then I'll just close it, and then I'll just start. Now I got it. But if you look at your 105, nothing is there because it's piped to VM, so the data is not really that fast. So I'll have to make sure these two options are enabled. These are like gain control. So you have RTL gain control, that's your main ADC to your USB gain control, and tuner is the main tuner that's tuning the frequency. So it has two gain control. So you can just close it. Yeah, now we can go to 098 or. And also the reception also depends upon the antenna position. So sometimes if your room is so covered with a lot of data, so you can just you won't really get anything out of it. So you can just move around. I would suggest you to install SDR Sharp in your native machine, because sometimes piping the interface is not going to work that easily. And also, just like your GQRX, you have your narrowband FM, you have your wideband FM, and then you just place it in. If this is, I don't think it's a frequency, but it's a small spike. Yeah, and then you have your normal raw wave, your lower sideband, upper sideband, your AM modulation, your narrowband, your wideband FM, and you can change your bandwidth. So bandwidth basically the size. Bandwidth. Yeah, and then the type of filtering. So that is not exactly needed because we are just going to watch for the frequency here, and then we are going to do multiple operations. Yeah. So here also you have just sort of pass things to get something out. So you can choose what output you need to put, where exactly you want to pipe it to. Let's say you have an external speaker or different output device, where you can just put it here. This is like the obvious stuff. And then since you are using the hardware AGC, this option is disabled. So if you want to enable it, you just have to disable it there, and then you can modify the slope or threshold, and then you can increase the frequency and the FFT. So whether you want the waterfall, or you want the spectral analyzer, or you want the both, or if you don't want none, you can also go with that, and then you can just put both. Yeah, and then this is the type of FFT filtering, or and then you have to select. It depends. I think most of it you can just stick with Blackman, because I think we will talk about these Blackman Hamming window, what is Hamming filtering, and then Hamming window, what is Blackman window, and what is USF. So we will talk about it in our future workshops. The resolution is what I told you, the number of points or number of resolution you want the FFT to perform. So if you increase it, it will consume a lot of your CPU resource, because it needs to perform multiple FFT in it. Yeah, it's also similarly a decay attack, so you can really like saturate it, or you can just increase it, make sure it goes fast. Also decay is also similar, you can just saturate it and then you can go similar for W attack and also W decay. And then these are pretty much we don't need to worry about. So this is your noise blanker, so it will just, whenever there's a noise, it just blanks it out. It's also similar to noise detection, but here it differentiates between the white noise. You know white noise, a normal hissing sound. So there you can use it to increase, you can also give up noise. So it gives a pulse, so you can see the pulse width. So it's more like your noise cancellation, not reduction, so where it creates its own noise to reduce that noise. So yeah, you can enable it, disable it, and then your noise reduction, your blank noise reduction, what dB you need to reduce your thing, or how much gain you want to increase it to, and your trivial recording. You can just record it. You want just the audio, or you want everything, or the what type of output you want. You want this 84-bit audio encoder, or you want a 16-bit or 32-bit PCM input, and then you can record it. Yeah, sorry. Yeah. So then your normal slider, and then similarly just like GK or X, you will find the place where you can put your frequency. Sorry. Yeah. So I think that's pretty much it for this SDR sharp. That's why I would always suggest you to use GK or X, because that tool is like really amazing. The UI and the UX is like really good. Sorry. Yeah. And yeah, that's pretty much it. And yeah, I'll just close it. Yeah, so thank you for watching this video. So I think we will come up with a lot of similar talks, so keep waiting.